Hello everyone. I'm going to talk about some technology which is not as fancy as microservices, but in fact it's the technology that we, all of us, use on a daily basis. And there is a technology which many of us treat as a black box, which is a terrible mistake, as is the technology that has a lot of leaky abstraction, I will mention in a moment, a lot of strange behaviors, a lot of pitfalls that are in Hibernate in JPA technology. And so at the beginning, just to introduce myself, my name is Jakub Kubryński. I work as I'm a co-founder of DevSkiller. It's a platform which verifies the coding skills of a software developers. So if you want to verify if someone is able to work with Hibernate, we can do that. We can even find if someone is capable of working in Scala. So it's platform that can do everything. I'm also doing trainings for Bottega company. I'm a program committee member of DevOps.pl, and I'm a co-author of the Spring Cloud contract. And that's enough for me. If you want to, you can follow me on Twitter. You can also tweet during the conference. If you have any questions that you would like to ask, just also drop in on Twitter, and I will do my best to answer it. So what I want to mention right now is that the current problem-solving algorithm is that you get some exception, you just copy-paste the stack trace into Google and try, repeat, etc. And often we do it using something that is called a cargo cult programming. So I'm just copy-pasting the answer from the StackOverflow, and I'm even not thinking if the answer is correct. Okay, and regarding JPA, there are two lives of the StackOverflow. One is before the Vlad Michalca, and the second is after Vlad Michalca. Okay, so when you see the answer in StackOverflow and the author is a Vlad, who is a member of the Hibernate core team, then you can copy-paste this without understanding. But any other use case, you just need to try to understand what's happening underneath. Okay, why? Because following the Joel Spolsky, he said that all non-trivial abstraction to some degree are leaky, okay? Which means the JPA and Hibernate is great abstraction over the database. But if you want to be successful, if you want your application to perform well, you must understand what are the SQL statements executed underneath the scene, okay? So it's not a black box. It's not a abstraction. It's something that we must understand fully how it works under the hood to be successful. Why? Because there are many, many pitfalls that you can do and many things that we are doing, and there is still no reason to do that. For example, let's go to the code. Can you tell me what's wrong with this simple entity? Is there anything that is incorrect here? Any ideas? I have some stickers of DevSkiller that I can give out. So, any ideas? Column. Yeah, there is a column annotation. And what's wrong with this one? Yes, it's totally unnecessary. You can remove this column and it works as well. Why? Because Hibernate and JPA persists all basic fields using the default mappings. So this column annotation does exactly nothing. Okay, so there is still no reason to do that. I can use column annotation if I want to change the description of the column, change the name, the length, say if the column is nullable or not, etc. But there is no reason to annotate every single field with column because Hibernate just ignores this annotation. Another example, what's wrong with this one? Transactional service, what? What's wrong with save? Yes, exactly. So the save is totally unnecessary. It does nothing because Hibernate uses something that is called the dirty checking, okay? It verifies that this entity, which is a managed entity right now, when I change anything, so I've changed the state of this entity, Hibernate knows that I've changed the state. So this save does totally nothing, okay? This entity will be persisted as well on closing the transaction by the Hibernate itself. So it verifies, it modifies the bytecode and verifies everything. So the dirty checking is enabled here. And one of my favorite stuff is that should I annotate the field or a getter? Okay? And there are almost religion wars in project that, yeah, annotate fields. No, 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 let's use methods, etc. So what do you think? It's better to have an annotation on a field or on a getter? Who thinks that field annotation is okay? Just raise your hands. Okay, so who think that it's better to annotate a getter? Okay, so fields are winning. So to be honest, it's not a big deal if you decide to use fields or you decide to use getters. It's better to use fields because when you're annotating fields, the engine is not using getters and setters. So if you follow, for example, the DDD principles, you don't want to expose each state of every entity, okay? I don't want to say that, hey, you can do everything. There is just public getter and setter. There is no encapsulation. When I'm using field, I don't need getter and setter. I don't need public access to this field. I can encapsulate the business logic. But what's the problem here? The problem is when people who prefer annotating fields start working on the same project with people who like annotating the getters. Why? Because even single annotation on a method is changing the whole access pattern for the whole class. So if you have some fields that are annotated with Hibernate mappings, and I will come to your project and I will annotate ID on the getter, all the fields are being ignored. No getter and setter on the field? Sorry, I won't persist it. Okay? Because Hibernate is checking this on a single, there is only one access type for the whole class. So if you want to use something that is called the mixed access, you must do it directly. I must say that, okay, so for this entity, use the field access, but for this single property, use the property access. Without this annotation, this single thing can change or is changing the access control on the whole class, which I saw causing the horrible mistakes on production, which was not cool, to be honest. Next example, what's wrong here? Simple entity. Just ignore, there is an ID inside, okay? But that's enough to find a fuck up. Yes, order is a keyword in SQL, okay? That's the problem. So what can I do? I can change the name of this entity. Yeah, it's the first answer of non-StackOverflow. Change the entity name. And now let's try what's happening underneath. Great, insert into orders, no problem with keyword. So I've already saved an entity. Let's try to load it. So select O from order O, and what's happening? Hey, there is no entity called order. Why not? It's here. I always use the class name. Not, you must use orders because you've changed the entity name. Not only the table name, I've changed the entity name. If you want to do it properly, there is a table annotation. It's similar to the column annotation. It changes only the SQL implementation while the entity name changes the JPA projection, okay? So that's a very simple thing to do a horrible fuck up. That was just the basics. Now move to something that is crucial for Hibernate. Let's move to mappings, okay? The simplest mapping possible is the one-to-one mapping, okay? What's wrong here? Yeah, where is the foreign key? On both sides. So Hibernate doesn't know which is the master of this relationship. So Hibernate uses two foreign key. There is foreign key from customer to the address and from the address to the customer. So happy deleting. How can I delete this entity? I cannot, because I'm trying to delete one side and it's not deleting. But Hibernate won't tell you that it would not delete it. Hibernate will tell you, okay, delete it. But the entity is still in the database. While Hibernate is saying, yeah, okay, cool, delete it. Great. So if you want to fix this situation, we must say the mapped by address. So now the inverse side must refer to the owning side using the mapped by value. And now it's the proper value when the customer is the owner of the address entity. Okay? Let's move next. One-to-many. What's wrong here? Okay, so I will try to help you. Do we need the join table for the one-to-many column? Okay, so don't tell Hibernate. They doesn't know about that, okay? So yeah, Hibernate will create a join table for this one. Why? Nobody knows, but they are creating it all the time, okay? So yeah, there will be a join column. So Hibernate will create a customer table, the address table, and a customer address table, okay? So if you don't want to use join column for one-to-many relation, then you must say, hey, use the join column for that. And now Hibernate refers this using the particular column, not the another table. Why it's important? Because, hello, joins are slow, yeah? I don't want my application to be slow, so I want to avoid joins as much as possible. So that's another important thing. But let's take a look at next thing. What's wrong with this one? Do we need a join column for many-to-many relation? Yes, that's how the SQL works. So a small hint. Do we need more than one join column here? Join table? Don't tell Hibernate, okay? Hibernate will create 2 join tables here. So there will be 4 tables. Customer, address, and address customer, okay? So without mapped by, on a many-to-many relationship, there will be 2 join tables just because it's funny. Okay? So that's how Hibernate works. So those are the pitfalls you can do when you are doing the mappings in a Hibernate. Okay? So let's move on. Lazy loading. Lazy loading is cool because everyone knows that when we are using the Hibernate or the JPA, we want to make use of the lazy loading feature because it allows us to load not the whole database, but only the stuff we need for the particular processing, okay? And everyone knows that if you want to use lazy loading, the entity must contain the default constructor with at least package visibility, okay? It must not be final, it must not contain the final methods, etc., okay? And that's true. But the real question is that we know that Hibernate is using JavaSys or CGLib, and it's doing proxy by subclassing, which makes sense because dynamic proxy for entities, hello, interfaces with getters and setters, it doesn't make sense. So Hibernate is just extending the class you are going to use. So if you have a user class and you want to create a proxy of this class just to enable the lazy loading proxy pattern, I'm just creating the entity user enhanced by CGLib extends user, and I can now use the lazy loading. But what's the common use case for lazy loading in JPA?
Lazy loading collection.
Exactly. I need to lazy load on collections. Okay? It's not common to lazy load fields like string, integer, or something like this one. And the question is, should I follow all these principles for the lazy loading to be able to lazy load the collections? And why not? Okay, so what is the collection? It's a list. What is the list in Java?
Order.
It's the interface. Interface, okay? So can I create the proxy of the string object? No, because string is final. Okay, we can create a proxy, but it's not the scope of this presentation. So I can provide my own implementation for this list. So I don't need to proxy the whole entity. I just can proxy this single collection. And that's how Hibernate works. So Hibernate is using those 3 implementations. So there is no set. It's not a hash set or tree set or something like that. It's persistent set. It's the set that is itself capable of doing lazy loading, okay? And there are three collections in Hibernate: sets, bags, and lists. What's cool? What's this collection? Is this a set, a bag, or a list? It's a set, yeah, exactly. What's important to the set? It's something that is native for the database, okay? Because set has no order and no duplicates. Just exactly as the database collection. What is important when you operate on the set and you remove something from the set, you just need the one delete statement to update the database state, yeah? If you're inserting something to the set, you must do two queries. One, to check if this element is unique, and second, just invoke the insert on the database. If you are deleting something, you just need to invoke the delete statement to remove it from the database. So it's great, and you should prefer the set everywhere in a Hibernate. Why? Because what's this one? Set, bag, or list? It's a bag. It's not a list. What's the difference between bag and a list? Yes, exactly. There is no order. But hey, I'm using a list because I want to invoke the get 0, get 1, etc. So there is an order. No, there is not. So in Hibernate, in list, there is no order. There are duplicates. It's a set with duplicates. Okay? And that's the problem. Because imagine the situation, I have some duplicates in my list. How can I remove from the database just one element while there are duplicates possible? I cannot. I must remove the whole collection from the database and then insert it one more time. Which means if you have 1,000 elements in this collection and you are using join tables, removing single element from this collection means removing 1,000 records from the database and then inserting 999 entities one more time, because Hibernate needs to recreate all this stuff, which sucks, to be honest. Okay? Also, when you're adding element to this collection, we also need to recreate it, because is it a duplicate or it's already inserted? I don't know. Hibernate also don't know. So you need to recreate it all the time. So using list here or collection, because if you use collection on a field declaration, it as well will be treated as a bug. It's the major mistake you can make using the Hibernate. So if you have something like this in your application, just change it to set as soon as possible. Okay? But I want to use order. I want to have a normal list. So then use the Hibernate list. That will be backed by the persistent list. I must specify the order column, which adds additional column to this collection just to preserve the order. And what's important right now, if you remove something from this collection, how many statements do I need to update the database state? Exactly. When you are removing the first element, you must update all other elements, because it's not using, you know, the something that we know from BASIC, that there is a line first, the next line is not the second line, it's 10, etc. So we can insert some. Hibernate is not using this one. So if you are removing the one element, you must change the order or for all elements that are next. After this element in this list. So it's also something that you must remember, because it has great impact on performance. So always prefer sets. Let's move on to my favorite topic, which is a n+1 select problem. Heard about that? Yeah, of course, everyone here. So what's the problem? Here is a user entity and list of addresses. And what I'm going to do, I'm loading the list of all users in my system, and then I'm iterating over the users, and then I'm doing something with the addresses on those users. And what's happening here? So I need one query here. So I've loaded the list of the users. Let's say that there are 10 users. Okay? I'm iterating over users. And every time when I execute the users.getAddresses, Hibernate is executing the query to retrieve the list of the addresses for this single user. So it means that if I have 10 users, then I will execute this query 10 times plus one select to retrieve the users list. So it means I will execute 11 queries just to process this stuff. And that's the terrible impact on the performance of your application. So how can I discover that there is a problem, the n+1 problem in my application? So there are two ways of doing that. First is the log analysis. When I see in the logs that Hibernate is doing much more queries than I expected, it's probably due to the n+1 select problem. And something that I ask you to do is turn on Hibernate logging on your stage environments, because often we are not aware of what's happening underneath. And often the queries generated by the Hibernate do some mistakes, okay? It's something that shouldn't happen on a production-grade system. So just read your logs and verify if it's strange or just a little bit strange, okay? The second way that we can do, we can use the Hibernate statistics to verify even during the integration tests. So if you have some part of your application that is crucial for the performance, that is processed all the time, etc., you can create an integration test when you are verifying how many collection fetches are there. Okay? If there are more than one query for such use case, then this test will fail. Okay? So that's another thing. But how can I solve this issue? So there is a workaround that is Hibernate specific. It sucks, but it's the fastest workaround possible here. It's something that I can use the batch size annotation and the size 10. What it means? It means that Hibernate knows that this collection is a part of some other collection because it was retrieved here. So when you will invoke the get addresses on the first user, Hibernate will load another 9 users from the collection. Okay, you are accessing this sub-collection. But the problem is that it works only if you are iterating over this collection in a normal way. If there are some if statements or something like that, it makes no sense. If you want to retrieve only the first address, sorry, I've already read the 10 another, okay? So it operates blindly. Okay, so it's just a workaround, not a solution for this problem. When you want to solve this problem, you just need to use the join fetch. I must say, hey, select user and fetch the addresses. I can also use the fetch all properties. For example, if you're returning the element to the UI or something like that, you want to build the DTO based on the entity. Just use the fetch all properties, and Hibernate will try to do its best to load everything in a single query. Okay, we can also use the criteria API, which is here from JPA to 0, also to mark that I want to fetch this property eagerly. Okay, because even if you change the collection and you will say, hey, this collection should be loaded eagerly, it doesn't mean Hibernate will do a join. It will also invoke another query, but eagerly. Not on the access, okay? So that's not solving the issue at all. If you want to solve, you must manually fetch these statements, okay? So remember about logs, remember about reading and analyzing what's happening underneath the Hibernate engine. Okay, so another fine situation is how can I save the entity in Hibernate? There are 2 methods on the entity manager. One is called the persist and the second one is called the merge. Okay? What's the difference between the persist and the merge? Anyone knows?
Persist generates key and merge can update the table if the entity exists?
Almost, yeah. So the persist deals only with new entities. So if you pass the managed entity into the persist operation, it will just ignore it. Okay, of course, persist cascades. So if you pass the managed entity, which has some new sub-elements or collections, it will the persist will cascade. But persist ignores the managed entities. If you pass the detached entity to the persist method, it will invoke the exception. Merge is pretty cool because it works for new entities and existing entities as well. Okay? There is one small, tiny thing between those methods I saw in the project where someone replaced the persist with the merge. Okay? Without changing any other code. Do you see any issue here?
If you merge, you need to use the return to entity.
Exactly. When you are invoking the persist method, the hibernate is persisting the entity which was passed as a method parameter. So after exiting the persist method, this entity passed as a parameter is a managed entity. Merge works in another way. It just the merge method is copying the entity state from the parameter, creating the new object, new Java object, persisting this object, and returns the newly created entity. So the entity passed to the merge method is just that after finishing this method. It's no longer a hibernate entity, which is a problem. So I can change the persist to merge, but I must also change the behavior because persist is void and a merge returns t, which is an entity. Okay? Also, because merge works with the new entities as well as the detached entities, how do I know if this entity is new or is just a detached entity? Should I invoke the insert or update? Sometimes when the ID is automatically generated by the hibernate, I know because no ID, it means new. ID, it's existing. But if I'm assigning the entity by myself, how do I know? I don't, simply. So what hibernate needs to do? Before every merge operation, it must execute the select to the database to check if the entity with such particular ID exists in the database. If it exists, then it's update. If it doesn't exist, it's an insert, which means instead of a single select statement for the persist method, I have two statements for the merge, just because I don't want to know if this entity is new or is detached. Okay? So due to performance reasons, I should only prefer the persist and use merge only for detached entities. Only. Okay? Let's move next. Optimistic locking. It's my favorite. Okay? So what is the idea behind the optimistic locking? It means that it's not so often that two users or two application threads are working on the same entity. Currently, because we are using a lot of reactive programming, a lot of asynchronous processing, it often happens that one thread is working on an entity, then another thread starts working on this entity, and there is a huge problem because it's not a concurrent situation, okay? If you are used to using, for example, MongoDB, which is a concurrent database, it works great with the reactive programming. JPA doesn't work with reactive programming at all. You will see the optimistic logging exceptions all the time. You must totally rebuild your model to be able to work in a concurrent manner. Okay? So the problem is that if we are using this classic approach without this reactive asynchronous processing, we don't want to lock everything in a database because lock brings additional cost. So locking and unlocking entities, when there is no race condition here, it makes no sense. So just don't lock it. Okay, great. But what happens if there will be two users that want to access and edit the same entity at the same time? Okay, so we must create something to recover from this situation. So we are creating a version of the entity. Okay? And imagine the situation. I'm loading the user, and this user has version 4. you are also loading this user with the same version. And then you are updating this user, you are saving this user, and I'm trying to save this user one more time. Okay? But the JPA tells me, hey, you have the 4th version of this user. Now, in the database, there is version 5. So, sorry, optimistic log exception. Okay? And I must repeat the whole situation. So we are providing the version field annotated with the version, which can be integer, but it also can be a, for example, timestamp, which is useful if you are thinking about doing the CQRS stuff. Okay? If you want, for example, to be able to pull the entities and pass those entities into another, I don't know, stream of events, into another database or something like that, it's better to use the version which is a timestamp because it's just a last update date for free. Yeah, you are updating this entity, so Hibernate changes the version to the current timestamp, so I have last update date for free, which is important because there is no built-in support for last update date in the databases. It's hard to say, hey, Oracle, give me all entities, all records modified in the last 10 minutes. Because Oracle will say, what? There is no such feature. Yeah? And in Hibernate, I can overcome this problem by using the timestamp as a version. But currently, all of us are moving from some backends like GWT, Vaadin, I don't know, JSF or something like that, to Angular, because it's cool. So we are moving to the REST APIs, okay? So what is about the optimistic logging REST? Simply there is no. Why? Because I'm not sending the entity to my customer. I'm sending a representation of this entity, a DTO, okay? So imagine the situation. I select the user from the database. I map this user into the entity. I've sent this into a DTO. I send this DTO to the user interface. User updates it. Send the DTO back to the server. And then what happens on the server side? I'm loading the user from the database. I'm updating the fields based on the DTO, and I'm saving this user one more time. So where is the optimistic logging? Not on the whole process, just on the last update, which means it's totally incorrect. If you want to do it better, you must send also the version to the customer. Say, hey, it's the user and it's version 4. And then I must manually verify if the version of the DTO and the version of the retrieved entity is the same. And if no, throw new optimistic log exception manually. There is no way that Hibernate will handle it. Remember about that, because it was the use case in 90% of the REST services I've seen. There were no optimistic logging. Okay, there was a field with the version annotation, but they were not using it. So that's the problem with REST, because we are not aware of this one. We are changing the GWT, which was operating on entities, to REST, and there is no entity information. Okay, so remember about that, because it's really crucial. Okay, another very simple thing, the identity. We know that every entity should provide an equals and a hashcode method, right? And it's simple. How can I implement the equals or a hashcode for the entity? What's the simplest way to provide an equal? ID. It's the common answer, but it's incorrect. Why? Yes, that's the solution, but for now I'm asking why the ID is incorrect. Yes, because new entity has no ID. Imagine the situation. You have the equals and a hash code, especially hash code, based on ID. I'm creating the entity, and I'm adding this entity into the hash set on the other entity, for example. Okay? Then I'm persisting this entity, and I say, hey, give me this entity back from this hash set. And hash set, there is no entity in this bucket. Why? Because the hash code has changed. You put this entity into the hash map. Oh, poor you. There is no way to retrieve it. Okay? Because the hashed structures must have the immutable hash code of the entity. So there are two problems. First is that ID can change during the life cycle because there is no ID at the beginning and there is an ID at the end. So we cannot simply use the ID. We must provide something that is called the business ID or the UUID for every single entity. What's the UUID? It's 36 digits. It's a lot. And I must save additional 36 digits for every record in my database just to be able to implement the equals and hash code. Okay, it's crazy. It's so giant cost. There are some approaches to be able to use this UUID, the Java implementation UUID, as a primary key, but it's not so efficient. Indexing this stuff, it's hard. Okay, there are some patterns to save it as a binary, 16 just binary, etc. But it's not working great. So that's the problem. If you want to deal with hash structures and you want to deal with the new created entities, you cannot use the ID. So what is the implementation that we could use here? It looks like this. I have the UUID, which is generated during the construction of this base entity, okay? And the hash code and the equals are based on this UUID. But this UUID must be saved into the database. And that's the horrible problem. And what is even worse, it's the simplest solution to this one. Okay, yes, but there is an additional cost of this. But that's how we deal with the problem of detached entities and the newly created entities. And that's cool, because this is simple, okay? If the UID is the same, it's the same entity. If the UID differs, it's a different entity, okay? So that's how we deal with the identity of the entities.
By the way, if you are storing in the database the UID, why not use it as a primary key?
Because of the costs of indexing it, of inviting, etc. There is a great post on a Percona blog about optimizing the UID as a primary key. And remember, it's Percona blog. Percona is an implementation of the MySQL that works in an active-active replication. And they are posting about this one. Also, Vlad Michalce on his blog post is also tweeting about this UID, using UID as a primary key, but it's not so easy as it should be. That's the problem. That's string, not a UID, mostly due to those things. Okay. Okay, so we'll move next. The caching implementation. Caching is very important in the JPA, and there are a few funny things with this one. So there are 3 different caches in a JPA. The first level cache, the second level cache, and a query cache. What's the first level cache? It's the cache that is enabled by default. It's no way to turn it off. Okay, and it works on the entity manager level, on the session level, so on the level of the single transaction. Okay, there is also second level cache that works on the whole application level, so it's shared between all transactions in the application. And there is also the query cache. The query cache that caches the results of the query, but results or just some representation of the results? So the answer is just a representation. So the query cache is working this way. Select all users or all employees with salary greater than 9K. Okay? What's in the query cache? The whole statement with all parameters is the key, and the value is list of the IDs of the entities. So just IDs, not the entities. So where are the entities? In the second level cache or in the first level cache, okay? So it's just mapping the query to IDs, and then another cache must think about how to retrieve those entities. And what is important to mention here are the flash modes, okay? What is the flash mode? So when you operate on a Hibernate, you operate on the entity manager, the entity manager is not sending the statements to the database, okay? It just keeps everything in the memory. So when are the statements executed? It's up to this configuration. The manual is when you invoke the entity manager flash. The commit works on commit. The auto, what's the auto? Is the commit? I thought so, but it's not, okay? Because the auto is on commit, on all commit of the transaction. So if you are committing the transaction, you're sure that there will be a flash. But what's happening if let's say that I've just created and inserted the user with the salary of 10K. And I'm executing the query, give me all users with the salary greater than 9K. Should this user be included in this query result or not? It should. So I must flash this user before executing this query. That's the difference between auto and commit. Auto say, oh, user, and you're asking for a user. I'm smart. I will persist this user and invoke the query after selecting this element. There were a lot of issues with invoking native queries because native queries were not allowed, not aware of the entities, and it won't cause the flash. It's fixed right now. Okay, but what are the pitfalls of the first level cache? What will happen if I will invoke the entity manager persist and then entity manager clear? The entity is gone because this entity lived only in memory, and I've cleaned the memory. Cool. So imagine the situation that I'm batch processing the entities. I'm inserting 100,000 entities to the database. All those entities live in a memory. And when those entities will be transmitted to the database on the transaction commit, which is a little bit late because flashing 100,000 entities, it's not the best idea, okay? So we can invoke the flash manually, okay? So I'm inserting, let's say, 1,000 entities and a flash, another 1,000 entities and a flash, another 1,000 and a flash. Good idea? No, not in Hibernate. Why? Because I flashed these 1,000 entities, and that's great. But after inserting another 1,000 entities, I'm invoking the flash. And Hibernate needs to process 2,000 entities. Another flash, 3,000 entities to process, okay? So I must invoke the flash manually, but immediately after the flash, I must invoke the clear, okay? I'm moving those entities into the database, and I'm cleaning the entity manager. I'm inserting 1,000 additional entities, flashing to the database, cleaning the manager, okay? If you will now invoke the rollback, all entities are lost, but there is no way to solve it. So remember about that. Operating on the entity manager works only on the entity manager until the flash method is invoked, okay? What are the pitfalls of the second level cache? It's very nice, distributed environment. Imagine the situation, I have a second level cache on two applications that works in a cluster. I'm saving the entity on the node 1, and I'm retrieving this entity on node 1. It's in my cache. Then I'm loading the same entity on the second node, I'm updating it, saving, and I'm loading this entity one more time on the first node. Do I ask database? No, it's in cache, but it's the old version. Oh, poor you. Okay? So if you want to use the second level cache in the distributed environment, you must also cluster your cache. And the easiest way to do that is to use Hazelcast, because it's not using JGroups as any other stuff. It's easy to cluster, okay? You can even use the Hazelcast as an embedded cache in your application. So if you are going to use the distributed environment and second level cache, always remember that this cache should be distributed across the whole application cluster. Because then saving the entity on the second node will notify the first node that this entity should be updated or just evicted from the cache. Because evicting is also okay. For the EH cache, the standard option was just to say, hey, evict this entity. Okay, so the entity wasn't updated, it was just evicted. So then I don't need to serialize this entity, I'm just saying out, okay? Next serious problem. We know that SQL injection is still the first on the OWASP top 10 vulnerability. But why? I'm using the Hibernate. Hibernate is smart. It protects me. No, it doesn't. So if you invoke such query, I know that I shouldn't do that for the prepared statement, but hello, it's Hibernate. Hibernate is smart. Hibernate is not smart. So invoking such query, when I will pass the category as the '1 equal 1, won't be escaped. Hibernate will just pass it to the SQL. So I've just created something that is called JPQL or HQL injection, and it works as well as the normal SQL injection. That's the problem. Remember that binded parameters are also necessary for Hibernate query language, for Java persistent query language, not only for the SQL, because it's SQL. What Hibernate will do, it will just replace the P with some aliases. It will replace the product with products, and that's all. All the parameters will be passed as they are, okay? Bind the parameter to avoid this one. Okay, so that was just a brief introduction to the Hibernate. Where can you find much more interesting details? So, the Vlad Michalca and his book, High Performance Java Persistent. Great book. If you are interested in this one, just read this. Blog of the Vlad, also great solution. And also, should I use Hibernate everywhere I start and every time when I start my application? No, it's not a golden hammer. It's not a silver bullet. There are tools like Juke, which allows you to create type-safe, statically typed SQL queries for Java, Scala, or Kotlin. And Juke is great. Just take a look at how Juke works. You can get back control on your SQL and not, just let Hibernate do the stuff. Also, if you are working with Hibernate, there are two crucial things that you should follow. First, read the logs. Analyze the Hibernate logs to see what's happening underneath. What's the schema generated by the Hibernate? What are the queries? Okay, what are the DDL statements? I must analyze that to see how my application behaves. And also debugging Hibernate. Verifying Hibernate implementation is crucial when you're running into some issues. You have issues? Debug the Hibernate code. Check why it's happening, why it's behaving so strange, okay? If you follow those all materials, you will be really successful at JPA, at the places where you should use this technology, because it's not the technology that should be overused. And that's all that I prepared for today. If you have any questions that I think we have a few minutes, like 2 minutes to answer them. So thank you very much, and there is a question. Microphone? Can we have a microphone? Remember that you can vote for the presentation if you like it. If you don't like it, just don't vote, okay?
Can you hear me?
Yes, but not through the microphone. Oh, just shout. Oh, it's working.
Okay. I don't really have a question. I have an objection.
Okay.
Because you said that batch size sort of sucks, and I disagree, because this is the strategy of dealing with N+1 problem that worked best for us, much better than eager fetching, and I will tell you why. A common misconception is that what the batch size means is the number of collection elements, but it's absurd.
No, it's the number of the collections of
collections of objects. So even we use large batch sizes like 50 or 100, because if you use entity manager find method to obtain just one entity, the batch size solution will work this way, that it will fetch only one collection, because there are no subsequent objects.
Yes, the problem I have with batch size is that when you are operating on the collection of entities, and you are then dealing with the sub-collections, which will be batch sized, and there is any logic here, like for example, I'm not processing all the entities, then Hibernate ignores it. There is it's not applying the access patterns. So if you're reading this every second collection, every odd collection, Hibernate doesn't know that.
Yes, but in our case, if you select, if you make a query and select multiple collections, that's usually to process them all.
Of them. Yeah. So, then this problem is not hitting you. So then you can definitely use the bar size.
Plus, in complicated data models, you often have many collections, and if you want to fetch all of them, you will end up in huge result sets, tabular result sets due to Cartesian product.
Yeah, but you are using when you decide to use join fetch, you're usually using distinct, and if you are using sets, then it's no problem, because if you're using bugs, there is a problem because Hibernate is not able to fetch more than one bug in a single query due to the duplications.
No, I mean that you have to duplicate the object fields along with the collection collection element fields, and you end up with big results.
Of course, that's the okay, because the situation you are describing is not a trivial problem.
Not a trivial.
Yeah,
and if you have two collections and both of them are eagerly fetched, then you multiply by the number of elements in the other collection.
Exactly. So then it's better to use the bar size. Yeah.
Okay, that was just
I agree with this
remark.
This
Thank you.
Okay, so there is no time for any other question, but I'm here. So if you want the stickers or if you want to ask me another question, just come. Thank you very much.